Okay, this video is over NAT addressing. So NAT stands for Network Address Translation, and I think the best way to talk about this is to kind of show you an example. So we'll look at what's considered a common home setup. So basically, on the cloud on the right, we have our home. And when we draw a cloud, there are devices in there. We may talk about what they are. We may talk about some of the devices. But these are all the devices in your home. And we're assuming that the network number for all these devices is 192.168.0.0. It's a /24 network. And then the private IP on the router really should be inside this cloud. It was just kind of hard to draw. But the cloud will be everything to the right of the router for your home. On the other side of the router, you have your ISP, and your ISP, your Internet Service Provider, is going to provide you with a public or a routable IP address, it is sometimes called. So this is a very common setup. Now then, as you know, you can have 5 devices as shown. They can be surfing the web, they can be streaming video, and all those work even though they have private IP addresses which are not routable. And the reason that works is because of something that runs on your router called NAT. Basically, NAT maintains something called a NAT table that controls communications from machines on the inside to and from machines on the outside of your router or outside of your home. So I'm going to show you a real quick NAT table. It'll look something like this. In this case, our inside machine 0.2 is trying to communicate with 142.250.191.206, which is Google, and is trying to communicate with Google on port 80, which is HTTP. So this is some type of web session. Same machine, different port number, dynamically generated, is communicating with 17.253.145.10, which is Apple, on port 443, which is HTTPS. So the same machine is carrying on conversations with the outside world on different randomly generated ports. One of the other machines in your home, 0.3, is trying to communicate with 52.96.214.50. This is Outlook.com, and they're using port 25, which is SMTP. So machine 0.3 has an email connection to Outlook. 0.2 has a conversation going on with 17.253.144.10, which is iCloud, on port 25. So this person is sending email through Apple iCloud. And then finally, machine 4 is carrying on a conversation with 98.136.103.23, which is Ymail, which is Yahoo Mail, on port 25. So it is sending an email. So a couple of web browsers, 3 different machines using 3 different mail services, all going on at the same time and being tracked by your router in its NAT table. So the NAT process is basically this. So for an example, let's look at our first entry, which was a PC retrieving a web page from google.com. So kind of simplified the diagram to this. You have a machine that has a private IP talking to a router that has a private IP, and it's putting information in its NAT table so that it can communicate with google.com. So I'll show you packet flows related to this. So this is the same diagram, just shifted up the page. So the first thing that happens is the user's computer will send a packet that shows that it's destined for Google. Since Google is not on its network, it will go to the default router, which is 192.168.0.1. The router will read that packet. It will put an entry into its NAT table about the conversation that's going on. It will then readdress the packet, listing the router's public IP address now as the source, same source port, same destination, some destination port. So it changed the source IP address from the PC that really sent it to the router, and then it will send that packet to Google, which will read the packet on port 80, presumably a web server port, and respond. So our response is going to look like this. So there's our diagram. First thing that's going to happen is Google is going to send a response to the public IP of the router. The router is going to read it and look up in its route table, looking for the source IP of Google and the source port being 61115. I'm sorry, the destination port that's going to on the inside. It will look up the entry in the NAT table. The router will then send a packet to, saying, hey, I'm 0.1, I'm sending this to 0.2 on the destination port of 5123, which was the randomly generated port that the conversation started on. And then the user's computer is going to receive the packet. So that's a discussion of NAT. NAT is a very important thing. It allows you to have a number of machines on one network communicating through a device such as a router, having only one public IP address, and keeping track of all the conversations. So that's NAT.